Uh, so the course content which we're trying to cover today is about threads. Now, the thing about threads is that operating system also has a concept about threads. So many of you, if you have been working in QA environment, or like you're a QA professional, quality analysis professional, uh, or say or say if you are having prior exposure of checking logs, etc., you know that Java runs as a separate process, and sometimes you kill that process and start the process again. And the process, etc., is not the concept which is there from Java end. That's a concept which exists from the operating system end. So every new thing, such as Java, etc., or maybe if you start a .NET or you start a Windows Word, everything starts as a new process, right? And once you start it as a process, then after that there are various threads which runs inside that process. So say if you are starting a Windows Word application, then that Word application, if you're opening multiple documents, they're like multiple threads from their documents. And this concept of threads is the concept which is actually related to threads. I mean, from operating system. It has nothing to do with exactly with Java. So what Java has done is that it has given you a way to have a control, or to have an access, you can say, to this particular class or to this particular feature. So threads in Java, it roughly mimics whatever we have for the operating system. Okay, so the very low level API, if you see, because the thing is that, I mean, the ultimate low level API of the actual implementation of threads, that is actually written in C, and it actually connects to the operating system, to the operating system's thread, uh, uh, which is obviously not in Java, so it connects using C. And that's why this thread is very much related to the operating system. So if it is Windows, the behavior would be a bit different. If it is Mac, the behavior would be different. So we need to take that thing into account as well. So that is what we have given in the introduction. Thread in Java is closely related to threads in the operating system. Whenever we create a thread in Java, there is a thread from operating system created. Okay, and there will be a process such as Java, which will be running, and there will be multiple threads which will be connected to this. Okay, and in Windows we have POSIX P threads. In Mac we have C threads. In other operating systems we have some different like threads. So the thing is that ultimately wherever you have installed the virtual machine, like whichever PC or whichever server, the operating system which is involved there, your virtual machine tries to create threads from that particular operating system. Okay, so every thread, once you do a create thread, it creates threads, but at the end of the day, this is an operating thread which is created. Okay, and when you if you have like say access to operating system, and maybe you have not coded, but you are slightly aware of some of the basics, and you'll find that, like say, if you create these processes and you're working on it, I mean, operating system decides from its own side, even though obviously, like, you can have multiple parallel things working, but which particular uh, item will get what time, and which will be done first, that is something which operating system has its own algorithm to decide, and we as a programmer can influence it to some extent, but not directly. Okay, so we also have so when you're exiting threads, and what you can just do is that you can start the thread, you can invoke it, but since it is related to operating system, you do not know when will it get executed. So normally if you execute threads, and if it's in order, it will get executed in order, but that is not something which is guaranteed behavior. Okay, so, and we'll see into the details as we progress further. Now, and that's what I've mentioned here. Since the thread in Java is closely related to the operating system, that's why it is up to the operating system to start the execution of the thread. We cannot guarantee when the order of the execution of threads. Okay. Now, multiple threads can work together to accomplish a common goal, and that is a basic idea behind giving access to just thread level APIs. So say for example, if you have to uh, start scheduling a job, right? And some of these things are so basic that we never give it a second thought as to how they might have got implemented. But in the back end, if you start thinking about it, there are multiple concepts which runs together. Say for example, scheduling. So scheduling is basically to schedule a job, right? To run it in regular intervals. And there can be various types of scheduling, like say a job runs every day at 5 o'clock, or maybe every 1 hour it runs. So there are different scenarios. Running every 1 hour is different from running today at 5 o'clock and then tomorrow again at 5 o'clock and doing the same day for 5 business days and then again repeating it after 5 business days. So there are a number of ways in which this can be done, right? Now, what multiple threads so in the case of scheduling, what happens is that there are multiple things which you need to take care of. So say I mean there are 5 jobs. Which job has highest priority, which job should run for how much time, and say if there is a job of high priority which runs for hours in end. I mean say there are 2 jobs which I have, or maybe 3 jobs which I have, and there is one job which is the highest priority, it takes 10 hours, and the other 2 jobs which are like say 5 minutes job and they have lower priority and they do not get time. So it is up to the operating system to decide how to time manage. And that's why whenever some people say that what will the execution of the threads, even though if you are trying to set the priority to it, and how we can set the priority we'll discuss, but even if you do that, I mean uh, operating system can decide like if it's taking more time to give a slice of time to some other jobs. So those things can be decided. So your priority can be ignored. So there can be like a way around it, and that all depends on the operating system. So whenever someone asks you a question like this, the answer is plain and simple. The behavior is not guaranteed. So I mean, it can happen in the same order. It can happen in the random order as well. That is not something which Java, I mean, as a specification, as an implementation, uh, gives any guarantee on to. Okay, so it is not up to the Java code to decide. Since we connect to the operating system here, it's up to for them to decide. Now, how to create threads in Java? So you create a thread in Java, and it gets we create another thread in the operating system side as well. So there are 2 ways in which we can do that. All right. So one way is that we extend the thread class, and the second is implement the runnable interface. So basically, if you see, there the 2 ways which I have described. One of the ways is so the 2 ways which I have described. One of the ways is through the what do you say abstract class. Okay, not abstract class. You can say inheritance. Okay, so which is by extending. Okay, thread class, and the second way is through uh, interfaces, and that is by implementing the runnable interface, right? So the thing is that this is very popular interview question and can be asked multiple times by different people out there, that which is a better way to create threads, whether it is by inheritance or whether it is via interfaces. And this basically at the very base level accounts for the simple question of what is the difference between abstract classes versus inheritance, and when to prefer what. So this is what it ultimately boils down onto, like what should be used. So first of all, let's go back to our example here. We'll create a default package. Okay, say com dot threads. That's our package, right? So once we create this package, we try to create a class. All right. So my class will be my thread. This is what I'm trying to write. My thread. Okay. So the way to create a thread class is via 2 ways, which we discussed right now. Either you extend a thread class or implement the runnable interface. So what is the meaning of extending a thread class? The meaning of extending a thread class is that there's a thread class which is already provided by Java. So, and that is the class through which Java contacts the operating system. Thread class, right? So operating system has its own definition of thread processes, and how does Java contact this? Through its own implementation. And if you go through that implementation, if you open the source code for the thread class, you will not find any place from where it directly connects or creates the operating system threads. And the reason is because about the native libraries which we discussed before, you can see some native code which is getting called from this particular class, the thread class, and after that it's a native C files which you have to open up and then see. Okay, and C files are not like Java files that you can just open it up and see. So if it is compiled, there's no direct way you can see. So you have to actually uh, check on the Java implementation source code to find out what they have given there. So anyways, you do not need to have this much level of knowledge, but I just wanted to let you know in case you're curious. So for the super class, we need to go and find the thread class. So this is what I was talking about, java.lang.thread. So go and select it. After that you click on finish, and this is what it creates. Alright, now I have created a thread class. Now if you see, it doesn't ask me to do anything. So there is no saying that this is not implemented or that is not implemented. So once you do a my thread, your work is done, right? So let's say I introduce another main method here. So to get the main method, what you do is you just type MAIN and then control space. It gives you an option of whatever thing is available, and then you select one of them and click on OK. So this is how it gets created. So I'll go here, my thread t1 is equal to new my thread. Alright, and I do like this. Now my thread has been created, but this is a constructor has been called. But to actually create a thread in operating system, you need to start this thread. That's how it works. So that is t1 dot start. Okay, go to the next line for better readability, t1 dot start. Alright, so once you start t1 dot start, now this means that the thread will get started. So if the thread will get started, that doesn't mean that the thread on the operating system side will get created. The actual code will start getting executed. It just means that you are done with the job. So what's the job from your end? The job from your end is that we need to create the thread. We need to start it. We need to start it for the thread to get created on the operating system side. We need to start it for the actual thread code to get implemented. So that we can only say by doing t1 dot start. So you have, once you call the start method, you have signaled to the Java JVM that you want to create thread and start the execution of it. When it gets done, it's not exactly in your hand. So here itself the operating system comes into play. It's not exactly into your hands. So depending on how many threads are already there, whether you have reached a max number or not, depending on all this stuff, the timing, etc., the operating system will invoke the thread, will accept your request to create threads. So even if you start at say around say 7:14 p.m. according to my time, it might be it might start at 7:16 or maybe at 7:15. So that thing is not guaranteed that when it will start working on it. Okay, now see if I run this code, what's going to happen. It just started, but nothing happened as such. Why nothing happened? Because it started, and every thread there is one method run. Okay, now if you open this thread class and see, and maybe it's visible, because in my case it's visible sometimes. Okay, yeah, so you see every thread class which is out there, and this is a java.lang.thread, right? If I go above, I see java.lang.thread. So this java.lang.thread, if you go below and look forward, it implements runnable. Okay, so runnable is a basic interface which from our side shows what is the it's an interface. All right, so thread also implements runnable interface, and runnable interface is a sort of contract which every thread has to implement. The runnable interface basically has a method run. Okay, and here nothing would have been provided by default. Okay, so if you go and see here, see, it just says target.run. And what is target? Target is basically the definition of, let's go. So target is basically the definition of runnable which I was talking about. So it just calls the run method on the runnable, uh, like the reference data type runnable. So here if you see, we have not provided any definition of runnable, right? So what it wants is, from our side, is that there's a run method, okay, which is provided by default. So there is already a default method which you call by super.run. So I mean, it was expecting a runnable interface which is already provided by default by Java here. But if you want some custom behavior, like say, if you want to do something from your own side, you need to define it here itself in the run method. Okay, let's say I do sysout dot inside run method. Okay, and after that I just start it. See, it gets called inside run method, gets printed. If you would have noticed one thing, we have not directly invoked run. Okay, we have not directly invoked run, we have invoked t1.start. So we have only started the thread, and internally, because of the implementation which we have out here in java.lang.thread, actually the run method gets called. Okay, so you need not open up source code and see, but I just, whenever I'm training, I sometimes think that it's better to give a slice of what's out there, so as to make you all like aware of the underlying backend stuff as well. So this is one way of creating threads. Now what was the second way of creating threads? That was implementing runnable interface. So there are two ways. One is through inheritance, which is we are extending the thread class, and the other one is using interfaces, which is we are implementing the runnable interface. Okay, so I go here and create a second thread. Let's call it, for simplicity, my thread 1. Okay, or maybe my thread 2, because we already created one, right? So you come here and create another class mythread2, and just go and write here implements and run, and then do again control space, so it gives you a number of options. I select runnable. Now it says, because you have to implement run here by default, because my thread class had extended thread class from Java side, which provides a default implementation. Alright, so if I go here, it asks me to implement the run interface. So I'll again go and add unimplemented methods. So here I can go and add any code inside the run method. So I add inside run to API. Alright, and I'll go to the main method and go and start it. My thread t2 equal to new my thread, this t2 dot start. Alright, so if you run it, you'll see that what gets printed out there is what we have. In the run method, which is inside, and this is happening because I have again created from here my thread classes thread. To create this one, you need to use my thread 2. Okay, so if I do that, what gets, and here see there's no ref my thread 2. I am doing a start, but this is not actually a thread. Okay, so if you see the difference here, it was my thread extending thread, so I had an option of doing a t1.start, but here this is not actually a thread, this is just an implementation of an interface which is used inside threads. Alright, so I can't directly go and create a new instance on a class like this. I mean, I can do this, but this is just like it will just work like a normal class, it will not be a thread. And there's no start API here, right? Because runnable is just a contract which just says that implement the run method. So how to do in this case? So what we need to do is we need to go and do thread, and this is thread is java.lang.thread, whatever the class which we're extending in my thread. So we go thread t2 is equal to new thread. Alright, and once you do that, you'll see various options. Alright, the one is I create using this particular constructor, which is a blank constructor. Okay, so if I do that, I can set the runnable interface after that, like say set name, set name, etc. I can do, or the second option is let's see here, we are giving the runnable option, the runnable interface reference here. Or you can go and give not only runnable interface reference but also the name of the thread. So let's do this. So we are going to give my like whatever you have out here. So for runnable, I can create runnable, and this is a reference data type, right? So I can just say runnable instance is equal to new my thread 2. Alright, so once I do that, I get a reference of runnable, I give it here, and for the name of the thread I'll just call it my thread 2. Okay, now you have got the actual thread which you can start. To run it this time, we'll get inside run one API. Alright, so these are the two ways which I was talking about. Let's move forward. One is extending the thread class, other one is implementing the runnable interface. Now I was saying, right, that when you start a thread doing t1.start or t2.start, that may not be the exact time when the thread runs. Okay, and this is a concept which you need to understand a lot, because of the operating system functionality, or say the, the level which it has as of today. You're not able to see those things in play, because my PC is hardly using any memory as of now. I just, instead of go sorry except GoToMeeting, I'm not using anything else. So I can go and start and run this my thread 2 or my thread, and it runs fine. I mean, you hardly see a time lag. But there is, I mean, if you run hundreds of threads or thousands of threads, you can definitely see a time lag. So it's very important to understand the concept which is involved here. Alright, so one is that the starting, I mean, once you do a start, at that time, I mean, it is in the new state, and then from there, like when the run method is called, I mean, once you, like, say when you do my thread is equal to new my thread, at that time this is in new state. When you call t1.start, that puts the thread in the runnable mode. Okay, and after runnable mode, whenever operating system wants to execute this thread, so it starts executing this thread. So in that case, if you go below, I mean, the next level is when it's when it actually starts getting executed, that is in running mode. Okay, and say because some reason or the other, you want to stop for some time from the execution of this thread, then you can put it in stopped mode, the hold mode, and that is called as non-runnable or blocked. So once it is non-runnable, again it has to come from the runnable mode, and then from runnable again to the running mode. So that's the whole process in which it works. And once the work is done, it goes into the terminated mode. So this is the entire thread life cycle. So you don't have any control on this life cycle, but understanding this is going to give you a lot of understanding in the way in which it works. So you have control over calling the start method. You have control over bringing this to closure. I mean, like by calling methods such as sleep or something, etc., which brings the threads into a non-runnable mode. Or after, once the run API is complete, like once you're done with this call, after that it goes into the terminated state. So your work here ends here. After the run method gets executed, it's up to the operating system to bring those threads to closure. All right, and we are like obviously say that now it has to be brought to closure. So that type of coding is already out there, but this is how it works. So this is on high level what we have for thread life cycle. Okay, now let's go again to what about priority. So I have been repeating number of times today about, like, say, even though if you start the threads as such, I mean, it's not guaranteed which thread will run what. Okay, and when will it run. And the reason for this is that everything happens so fast that you're not able to see the difference. Okay, so like, say if I start 5 threads in one go, but there will be a slight time lag, right? So with the fifth thread, with the last thread which I started, had the highest priority. But in the case when you actually reach that till that level, you have already started with the other threads. So operating system can either like do a time slice, that it can stop or other threads for some time and you will not notice it, and start this particular thread, and once it gets completed, give the control back to the other thread. Or maybe, I mean, it can start both the threads in parallel, you never know. But setting priority, I mean, Java gives an option of setting priorities, and setting priority can help you define like what needs to be done better way. Okay, so at least like you will make the operating system aware that what is the preference. And when you set the priority at the base level, I mean, if you see here, there are like say I'll show you how to set the priority. So to set the priority, what we do is, if you go here T2, now this is a thread, right? So we do set priority. Okay, so this priority varies from, I think, 0 to 10, 10 being the highest. So you set the priority here, and default is 5. So if you do not set, default value 5 would be set. So you're setting the priority here, all right? Now this, inside the implementation for this, if you go and see, it actually calls the set priority API, another method which is there on the thread class, or whatever you call it, on the operating system side. So in a way, you influence the priority of the thread which actually gets created on the operating system. And the way to do that is via this particular API. Now, operating system in itself might not use that particular priority. Okay, that priority in some cases, say, I think I have heard that in Windows it's different, in Mac it's different. There are some operating systems which have this API, but they hardly give any value to it. So even though you set it up, it might not work properly. But there are others. So I mean, what it means is that you need not depend only on this priority to decide the order. If the order is so important, you need to do something programmatically here. You need to design your applications in a better way. But in Windows, etc., if you set priority, I mean, at least Windows takes that thing into account. And unless it runs into a situation where there is some thread which is hogging up all the things, it can go ahead and actually go ahead and run it for you. So what I mean is that, like, say, I mean, whichever thread has higher priority, that thread will run first. So that's how it works. Okay. Now, so thread priority. So we can influence thread's execution order by setting the priority on the thread. This can positively affect the execution order. However, this will also never guarantee the actual execution order. The priority level ranges from 1, which is the least important, to 10, which is the most important. And if no level is explicitly set, a thread instance has a priority level of 5, which in other words means that the default value of the priority attribute on thread class is 5. Okay. Now, coming back to wait and notify. So what about wait and notify? So if you go and see, not only thread class but every class, even if I create employee class, all right, so let's go ahead and create. So even if you create employee class, there is a particular method on this one which is called as wait, and there is a particular method which is called as notify. Okay, and this method is there in the object class itself. So object class is a basic class which every class extends. Okay, now I go and create a class employee emp, and I am now creating an instance of it. So if I create an instance of it, and I just want to show you emp dot, say, you'll see wait. Okay, you'll see notify. So there are two APIs which is out there, emp.wait, emp.notify. So what does wait do, what does notify do? So what wait does is that if I go like this, what wait does is that it asks, like, say, everything, I mean, even if you create threads or not, like, even if I say, like, go and run it, internally there is a thread which gets created, right? Because operating system has to run it. So inside the Java process, there is a separate thread which gets created, and it executes this piece of code. But we want to stop this particular thread, alright, which is implicit here. It is not explicitly you have created, but that implicit thread you want to stop execution for some time. Why? Because maybe you want some other work to get done before you actually work on this employee. So maybe employee has a method which is, say, public string get salary, all right, and this thing has to get called only once you set the number of days which the employee has worked. Okay, and that is not directly here. Okay, so let's say you just return here, for now, just to avoid this error, return null, and you have an attribute here which says int number of days worked, and I'm just giving this example to help you explain you get the concept better. You may come back and say that this is not a valid example, and why do we have number of days worked as an attribute inside employee? But that thing all depends on the design, not directly related to what you want to do. So this number of days worked is out there. Now that using this you need to calculate the salary. So unless if this is out there, I mean if say if null is equal to number of days worked, and not null, not because null is used here, we have to use 0 because it's an integer. If 0 is equal to number of days worked, alright, and in that case you wait for some time. Okay, now yeah, so you wait for some time. So if you wait for some time, you can just say this dot wait. Okay, so you can pretty much do this. So you wait for it. Now say there is another thread which actually updates this number of days worked. Alright, so there is another thread which gets created which actually updates uh, this number of the number of days which it has worked. So what that will do is that once it comes here, it will like, and this is just a second. So we just add a declaration so that you don't have any uh, compilation errors. So there is another thread which comes and it updates the number of days worked. So in that case, what should happen is that this wait should go over. So this particular thread should be able to move forward. Alright. So what we'll do is that here itself we'll add another uh, API, say public void set number of days. And what this does is it accepts int n as one of the parameters, and then it goes this dot number of days worked as n. So here you're setting the number of days which it has worked. So once set, you want to notify all the threads which are waiting for this one on this particular object to see that it's done. You can go ahead and actually start working on it, right? So if the number of days is done, so if you are done from here, so what you need to do is that you need to call, say, this. Okay, this dot notify all. Okay, now what it does is that any thread which is waiting on which is waiting on a particular monitor. So when I say that, what I mean is that when you do this dot wait, this is an object, right? So you don't wait on an object, you wait on a monitor. So like, what is a monitor? So the thing is that there is a synchronized API, all right, synchronized keyword, and that works in two ways. So you have it works on the objects, so you can specify it in this way. Okay, and inside that you can move this piece of code. So the significance of synchronized keyword is that in multi-threading environment, all right, so say in multi-threading environment where you have multiple threads which gets created. So there, if you want that, say if one thread enters at one time and the other thread enters at, like, say 2 minutes later, or maybe there are hundreds of threads which are coming at the same time, but you want to ensure that a piece of code is out there which only gets executed one by one. So it's not that multiple threads work on a piece of code at the same time. Whatever is this particular execution, all right, the only one thread should get executing over it, like should execute it like over one time. For that we use a synchronized queue, which means that unless a piece of code this piece of code is getting executed by one thread, there will be no difference. The other threads will keep on waiting, okay, and they'll only execute this when it's free. So this ensures that if there is some, and the keyword which is used here is thread safe. So if there are some APIs which you have to write which is thread safe, that is the behavior does not change in case of in multi-threaded environment, then in that case you need to use synchronized keyword for that particular method, or maybe inside that particular method for a particular block as well. So here, I mean, it's asking this particular thread which is executing, and say implicitly everything is working on threads, all right. So this particular main, you write and you do a right click and say run as Java application, it actually creates a thread for it to run, and that thread stops or finishes very fast. So that's why I mean, you do not see a difference, but ultimately it's a thread, all right. So coming back to here, so this was for synchronized keyword. So only inside a synchronized block you can ask a thread to wait. If the synchronized block is not there, that essentially means that, I mean, there are multiple threads which can work together, and you do not know which has to be waited and why, because only if it is synchronized, one piece of code has to get executed by one thread at a time, and if that is not the case, the same piece of code can be executed by multiple threads. So there is no concept of waiting. The concept of waiting comes only along when you are writing a thread safe application in a multi-threaded environment. Okay, so that's why only inside a synchronized keyword will this wait work fine. And similarly, this dot notify all. Okay, now if you see this when there is a separate thread which can set the number of days, all right, and there is a separate thread which can try to get salary. Now if you do a this dot notify all, it is, if you see this one, it's looking for, it wakes up all threads that are waiting on the object's monitor. So whenever you create this particular object employee, at that time on that particular object, whatever is a monitor associated, it will whichever class is waiting on it, it will try to notify all of them. But since there are different objects, there are different monitors, so it will notify different objects altogether, and like it will be different from this particular list, and there lies a disconnect. Okay, so to work on that disconnect, what we need to do is that, say, we specifically need to create an object, okay, and then work on it as, say, when you create object like this, and maybe you can like put it as a log, okay, and this may be one employee object, all right. So say I can define it as, say, static. So what that essentially means is that there is only one log object for the entire employee class, and once I go here I can use this as the object on which I need to create the synchronized block. And similarly here as well, when I'm writing it, okay, so when I'm writing it here, so I'll go here and write it. I can work on the same synchronized block. All right. So once I do this, what will happen is, say, I'll start different threads. All right, and just so that I can do it from the same API from here, just for my simplicity, let's implement run. Okay, so since it's giving that error because I've not implemented run API, go here and run it. So what this basically means is that maybe I'll go here and create employee emp, all right, is equal to new employee, all right, and do emp, I maybe I create a new thread t1 is equal to new thread, okay, and then do a t1 dot start. So if I run this, like, say, every time I go ahead and I've already done it, say maybe I do not need to create this stuff, I only need to I only want this object to get created, okay, and I could have created a different object altogether and a different implementation or run, but just to keep the code small, I integrated both of them. Okay, so this piece of code might not is not required here. This piece of code will go and add in the main method, so we can start it from here. So you have a t1 start, all right, and then you have another thread t2, which it has t2 start, all right. So you have these two threads which start. So what these two threads will do is that it will create two employee objects, all right, which are nothing but implementations of runnable. Okay. Now, if I go here and say uh, I need to go and do a MP dot get salary. All right. So one thread, if you do like that, say emp dot get salary, and I can get a reference for it as well, right? So I can go and start that thread and get a reference for it. So it will wait, okay, for infinite time until there is another thread which comes up, and it actually sets a number of days work, and once done, it notifies every other thread which is waiting. So if there is one thread which is waiting here, one only when the number of days worked is set, it will go here and notify that this is waiting. Let's get over with it, and after that, it returns actual salary computation. So this is how we like the wait and notify works together. So we go back and see here. So object class has wait and notify methods. To execute the wait API in the object, we need to be in the synchronized block. With every object, there is a monitor associated. In a multi-threaded environment, if there is a piece of code which can be executed by only one thread at a time, then if the executing code needs to take control of the monitor. And the way to take control of the monitor is that the synchronized keyword you have to use, and then you have to write the object. So you can, instead of using lock, you add this. But the problem with that is that it's like taking a direct control of the monitor, which the next object which you create will not have. So that kind of reference we need to avoid. So that's why we have created a generic lock itself, one object which we call it as lock. Okay. Now coming back to here. So wait API will let the thread wait for it to be notified that it can proceed further. Theoretically, it will wait indefinitely. So until you call notify, it's going to wait. So if you go and see this code, we are calling notify all. Then another API notify. So what notify does is that if there are hundreds of threads waiting, it will notify randomly one of them that you can go ahead and proceed. It will not notify other threads, but notify all will let every other waiting thread will let all the waiting threads to proceed with the execution, and they all can start the execution at the same time. And maybe if there is a synchronized block, only one of them will get the access, the others will wait until it's actually done. Okay, so that's how your your uh, wait and notify uh, theory is all about. And coming back to producer and consumer problem, so there's one very basic problem in you can say a programming problem in threading concept, and that is about producer and consumer. So what it means is, let's try to understand it in this way, that there is a producer, and there's not one producer, there are like say 10 producers, and they keep on producing a certain type of object over and over again. Okay, but even if they do that, these objects needs to be consumed by a different thread. Okay, so it will start consuming, but producing might be faster. Consuming this thread might involve some logic, it might take some time. So what I mean to say is that there will be a difference between the rate of consumption and the rate of production. All right, and there can be a situation where, I mean, you're creating more threads, you're creating more objects, but you're not able to consume it, and maybe there are, in such ways, there are objects which are getting lost. Okay, you're not able to work on it, or maybe if the threads are not producing anything, like say if the consumption was done, after that your consumer threads are just trying to execute a null object, because they always expect that some produced object has to be there, which in this case is not is not the scenario. So this is a very common problem which is called as producer consumer problem, and there are various ways to solve it. But the way in which we are going to do here is by using wait and notify APIs, which we have discussed. Okay, and that's why I just wanted to give that concept about wait and notify before, so that we can go through it and understand the problem in a better way. Okay, so let's read the theory here, which is producer can keep producing objects forever. However, the rate at which it will be consumed by the consumer can be different from the rate of production. There has to be synchronization between the producer and the consumer. And this is what the producer consumer problem is all about. So if you see the producer consumer solution, what we're just doing is we're creating two threads. One is a production thread, one is a consumption thread. So this production thread, I'm just starting a producer, and size is 4. So I'm just starting 4 producer objects. Okay, and you'll see how, and I'll create 4 consumer objects. Okay, and name of this thread, one thread is producer, one thread is consumer. So if you go below and see, this is one producer which implements runnable. All right. So here whatever we pass has to be has to be of type runnable, right? And this is what we saw while creating threads using interfaces. So this producer implements runnable. It's referring to a shared queue. That shared queue is what we have defined here, but that shared queue is, I mean, we have like defined in the top itself. So that shared queue is used by both production thread and the consumption thread. You see shared queue. So this shared queue, if you come in size mentioned here, so that's why we mentioned the size here, which is 4. So if we come below and we have initialized it, the run API which does is that it keeps on calling one API produce. So here if you have created 4 producer objects, 4 times this run API will get called. Alright. So 4 times this run API will get called, which calls this produce method 4 times. So if it calls 4 times, what's going to happen here is, I mean, there is a check for whether the queue is full or not. But if it is not full, just for a second try to understand that this piece of code doesn't exist. So if it doesn't exist, what we have is synchronized shared queue. So because shared queue is common, right? It's common between the production and the consumption threads. That's why that synchronized block is needed, so that only one thread can enter that particular block of code at one time. Okay, so you synchronize on this object, and this object is fine because this object is being shared by both producer and the consumer. So in the shared queue, which is basically a vector, I guess, right? Yeah, it's a vector. So you go ahead and add I. What is I? So I is nothing but one particular number you just want to add to this shared queue. And once done, you want to do a notify all. So what this means that any other thread which is waiting on this particular shared queue has will get notified, and one of them will again try to get will again start executing. So what it means is, like, let's go above and see. So in this way we are adding one by one elements inside the queue. What if the size is 4, right? I have reached my size limit. So if we have reached my size limit, shared queue dot size is 4. So what this means is that I have to wait because my limit is full. The maximum I could have created, the number of objects or anything else which would have not got consumed by that time is 4. So say if I create 4 objects, all right, and three of them get consumed, so only one object is there in the queue. So if only one object is there in the queue, I can keep on adding on 3. But if the consumption is slow, there will come a time when all the 4 objects are created, but none of them are consumed completely as such. So the shared queue will be full, and that is what is signified by shared queue dot size is equal to size, and this is just a constant, which is 4 in our case. So here we are again synchronizing on the shared queue item, shared queue vector which we have. This is just this out, and here we are asking that let's wait. So the shared queue object has to, we are putting a wait here. So what this means is that this particular thread which is executing this has to wait. Okay, so has to wait for some time. Okay, and what is that sometime? That sometime will come from, say, this notify all. So this notify all will also notify every waiting thread, but in this case, once we reach the limit we are waiting on it, there can be another thread which goes inside this. How that happens? Because once the shared queue size is 4, how will that get reduced? The answer is towards the consumer implementation. So let's come here and see. So if you see this consumer implementation, again this thing is same, but what we are doing here is that we are just trying to we're just trying to sleep for some time. Okay, thread.sleep, and we are just calling the consume API. So what consume API is doing is, I mean, that I've not put here. What consume API does is that it goes out, all right. It goes out and it tries to remove an element from shared queue. So it will do shared queue or remove I. Okay, so it removes an element and do shared queue or notify all. So what that means is that this which is waiting, it will come out. So why? Because shared queue size has become smaller, and then it will keep on adding it. So, and the other threads which are coming on, for them the size is not 4 because some of the consumption has already been done, so they will directly enter inside this block. So that's how, using wait and notify all and maybe notify, we solve the producer consumer problem. Okay, now the thing is that this might seem to be a bit complex, but once you do a reading from your end and try to look through all these questions, it will become simpler. So I'll just suggest that you like take a shot at these questions, And most of the questions you have mentioned here are theoretical questions till here, number 4. The reason why is that I want you guys to read about blocking queue, what is volatile keyword, what is concurrent package. If you look for such questions, you'll get multiple other things which is out there, reference to them, and that will help you to clear all this concept in a much better way, much faster. Okay. So this is all about threads today. If you have any questions, you can ask me. Otherwise, we can dismiss.
Hi. In the